Neeraja from MEC, Department of Physics, from Basic Science and Humanities. Now today I am going to discuss about the topic of lasers. So in this lasers chapter, the topics which we have covered in this chapter are, the first one is an introduction part, and the second one is a characteristics of lasers, and the next one is principle of lasers. Then now first we are going to discuss about the topic of introduction. Laser is stands for light amplification by stimulated emission of radiation. So here we can consider that this is a laser, acronym of laser is considered as light amplification by stimulated emission of radiation. So this means that the light is amplified on the basis of process of stimulated emission. That means the stimulated emission is a process, and that process some amount of radiation is produced. That amount of radiation will be called as a laser radiation. So that we can say that laser is stands for light amplification by stimulated emission of radiation. So now first we are going to discuss about the characteristics of lasers. So we have totally 4 important characteristics of lasers are there. The first character are considered as high directionality, the second one is considered as high intensity, and the next one is considered as high monochromaticity, and the fourth one is considered as high degree of coherence. So first let's discuss about the directionality. So here we can say it is a high directionality. Before we are going to discuss about this directionality, we have to know about the conventional light sources. So what are the conventional light sources? The conventional light sources means on all type of ordinary lights we have considered as a conventional light sources. In these ordinary light sources, we can say that the light is moves in all directions. That means the light is diverges in all directions. So by the process of spontaneous emission. So the conventional light sources are moves in all directions due to the cause of spontaneous emission. But on the other hand, we can say that the laser light source moves only in one direction on the basis of stimulated emission. So we can say that the directionality is one of the characteristics of lasers, because the laser has only one direction. So here we can see the diagram of laser light source, as well as we can see the diagram of conventional light sources. In these two, we can say that all the light rays will be moves in all directions, but laser light rays moves only in one direction. But the laser directionality is also expressed in terms of divergence also. The divergence will be calculated in terms of delta theta is equal to R2 minus R1 by D2 minus D1. So here R2 minus R1 will be considered as a laser beam of source, and the radius of the laser beam of the source, and D1 and D2 will be represented as a distance of the laser light source. Then coming to the next one, the second characteristics of laser will be considered as an intensity. So we know that based upon the directionality of the laser beam, the laser light source has high amount of intensity. So that means why? Because they have a high amount of intensity is the total radiation will be concentrated in a small region, so that the concentration of energy has a high amount of intensity. So that we can say is that the laser light source has a high amount of intensity. So for example of the laser light source, we can see that 1 watt of laser light source is 1000 times more than that of the 100 watts of ordinary lamp. We can say is that it is a 1 watt of laser, and ordinary light source is a 100 watts of laser. So it is 1 watt of laser is 1000 times more than that of the 100 watts of ordinary lamp. So that based on that, we can say is that the laser has a intensity, high intensity, because all the emitted waves are in phase or coherent sources. These coherent light beams will be considered in terms of the total resultant intensity will be taken in terms of NA square. So then this Na will be considered as a number of waves and A is considered as the amplitude of each waves. Here the resultant intensity will be considered in terms of sum of individual intensities, and that is proportional to Na square. So this will be considered as high amount of intensity. So this is the second characteristics of laser. And we can go to the third one, that is high monochromaticity. So in this high monochromaticity, the laser light source has high amount of energy because all the photons have same energy on the basis of the ground state and above the ground state. So this all will be considered in terms of an equation, that is h nu is equal to E2 minus E1. That will be considered as nu is equal to E2 minus E1 by h. So on the basis of this energy, on the basis of the high intensity, on the basis of the one directionality, we can say is that the laser light source has a monochromatic light, because mono is a single. So because of single direction of the laser light source, all the photons has the same energy and have the same amount of intensity. So the laser light source has a best monochromatic source of light. Then the last character is considered as a high degree of coherence. In this high degree of coherence, we can say is that the laser has a high degree of coherence because all the photons are in phase. Then that means we can say is that the laser light sources have high amount of intensity, high amount of it has a single direction, and it has a same wavelength, and it has the same frequency. All are in same phase also. So this the purity of the spectral lines. So that means the light of the spectral lines will be expressed in terms of the coherent light source. Due to its coherence only, it is possible to create high power in space by using laser light source. So these are the mainly four characteristics of lasers. These four characteristics will be considered as, one is a directionality, and second one is an intensity, and third one is a monochromaticity, and fourth one is a coherence. So these are the mainly four characteristics of lasers. Now we are coming to the principles of lasers. So based on the principles of laser, we have totally four types of principles are there. The first one is considered as an absorption, and the second one is considered as a spontaneous emission, and the third one is considered as a stimulated emission, and fourth one is considered as a population inversion. So these are all will be considered as a principles of laser light source. So first of all, first we can discuss about the topic of absorption. In this absorption topic, we can consider that initially all the electrons are present in the ground state itself. We know that. So here we can consider E1 and E2 will be considered as a ground state and excited states. So here N1 is considered as a ground state and N2 is considered as a excited state, as well as E1 is considered as a ground state and E2 is considered as a excited state. So we know that initially all the electrons are present in the ground state itself. For that ground state electrons, we can apply some amount of energy to move the electrons from the ground state to excited state. So when the electrons are moving from ground state to excited state by the applying of some amount of energy, then all the electrons are moving from ground state to excited state. So on the basis of that, we can say about the definition of or the statement of the absorption considered as the process of moving electrons from ground state to excited state with the supply of energy is known as absorption. Or else we can also consider that an atom or molecule are initially present in the ground state E1 and can absorb the photon of energy h nu. We can apply some amount of energy h nu and it goes to the excited state E2. This process is known as absorption. So here we can also specify the rate of absorption. That rate of absorption will be considered as B of 1 2 into rho of nu into N1. So here B of 1 2 is considered as 1 is considered as a ground state and 2 is considered as an excited state, and rho of nu will be considered as an energy density, and N1 is the concentration of electrons in the ground energy level. So these are all will be considered in terms of an absorption. The next principle will be considered under spontaneous emission. The spontaneous emission will be comes under the emission of electrons from excited state to ground state on their own without supplying of any energy. So here we can consider this spontaneous emission after completion of absorption. So after completion of absorption, all the electrons are present in the excited state itself. So in that excited state electrons, we can apply some amount of energy, then only the electrons will be comes back to the ground state. But here we didn't apply any amount of energy to those electrons which are present in the excited state. So but the electrons are moving from excited state to ground state on their own because they lose their lifetime in the excited state. The excited state electrons has a lifetime of 10 power minus 8 seconds. If the electrons has lost their lifetime, then automatically all the electrons will be comes back to the excited state to ground state itself. So here we can see is that the spontaneous emission will be considered as the emission of electrons from excited state to ground state on their own without supply of any energy is known as spontaneous emission. So here we can say is that the excited atoms does not remain in the state for a long time. After a short interval of time, that is 10 power minus 8 seconds, it falls to the ground state by emitting photon of energy as shown in the figure. So here also we can consider E1 is the ground state and E2 is the excited state, N1 is considered as a ground state and N2 is considered as an excited state. Here we didn't apply any amount of energy. Here the excited atoms jumps from ground state to excited state to ground state on their own, hence that process is considered as a spontaneous emission. So here also we can write the rate of spontaneous emission in terms of A2 1 into N2. So here 2 is considered as an excited state and 1 is considered as a ground state and N1 is considered N2 is considered as a concentration of electrons in the excited state. So here A12 is considered as an Einstein coefficient and N2 is the concentration of electrons in the excited state. Then now coming to the main principle of the laser, that is stimulated emission. So we know that the acronym of laser is light amplification by stimulated emission of radiation. So in this process we can say is that the emission of electrons from the excited state to ground state with the supply of energy. So here the stimulated emission is also considered at the time of after completion of absorption. So after completion of absorption, all the electrons will be present in the excited state itself. So for that excited state atoms, the electrons are moving from excited state to ground state by the supply of energy is considered as a stimulated emission. But we know that when the electrons are moving from the excited state to ground state, it releases some amount of photon of energy for the electrons. So here we can consider in the stimulated emission also we can apply some amount of energy, then when all the electrons are moving from excited state to ground state, it releases more amount of energy in the form of radiation. So that radiation will be considered as a laser radiation. So here we can say is that the laser means the light amplification by stimulated emission of radiation. So this process is considered as a stimulated emission. So here we can consider the acronym of laser is satisfied here. So the main principle of the laser is considered as a stimulated emission. And the last principle of laser is considered as a population inversion. So in this population inversion, we are all known that all the electrons which are present in the ground state initially. So initially all the electrons are present in the ground state, but we can apply some amount of energy to those electrons which are present in the ground state, then all the electrons are moving from ground state to excited state. So here we can say about the population inversion as we are finding more number of electrons in the excited state compared to the ground state is considered as a population inversion. So here the population inversion is a pre-required condition in order to have a laser radiation. So to produce the laser radiation, this population inversion is a pre-required condition. So based upon these four principles, we can produce high amount of laser light source.